So now we have a recording. And we'll start with the beginning. What is ClickHouse? ClickHouse is a database management system. It understands SQL. It understands SQL so that all the, maybe not all the functionality of standard SQL is supported, but a lot of it. And most of the BI tools are able to connect ClickHouse and send queries, and ClickHouse will understand what they want. There are, of course, some extension to SQL syntax for ClickHouse features, for ClickHouse specific features. But yes, the idea is that BI tools can work with ClickHouse, and if you know SQL, you can just start writing queries, and most likely you will be able to just ask what you wanted to ask, and you receive an answer. ClickHouse runs on Linux. It means that anything you can install Linux on, ClickHouse can run. And this, of course, brings a lot of possibilities, and you can run ClickHouse anywhere. Shared nothing architecture means that you can create clusters very in a flexible way. You can combine different kind of machines, and you can have like some parts of your cluster in the cloud and the other parts on bare metal, for example. And shared nothing architecture allows you to do that. ClickHouse is a columnar store, and it sorry about that, just a few more people. Don't want mute. Okay. Okay, great. The question: do they follow some certain SQL standard? They are trying to support the standard, the NC standard SQL sentences. And other than, also they, when they implement some features, they often look at MySQL and Postgres. If they implement in something and they not, maybe if it's not in standard, but they won't be compatible with other tools. So they look at examples from Postgres and MySQL. But and of course some ClickHouse specific features. Yes, I was saying that the storage is columnar, and this of course makes ClickHouse, allows ClickHouse to scale to many petabytes, and also the possibility of parallel execution. This is also facilitated by the columnar storage. ClickHouse uses vectors of values to parallelize execution and speed it up. So this is what makes ClickHouse fast and gives a great performance. Another very valuable feature of ClickHouse, it's open source, and a lot of features were actually introduced by third-party developers, and it's still happening. There are a lot of contributors, and the core development team, they try to merge almost everything. There are a lot of, I kind of monitor the activity of the project, and very few pull requests are getting closed. Most of them are merged, and if someone starts an interesting feature, and the core developers help the third-party people to finish these features, and they are very welcoming. So let's look at why why and how ClickHouse is so good. of course, it's an online analytical process database because it is supposed to handle a lot of data. It is analytical processing, which is, so the idea is that you have a lot of data and you want to ask a lot of different questions to your data. And you don't necessarily know in advance what questions you're going to ask, and probably over the time your data is going to change. And so what the idea is that you store all data that you have, and then you figure out later what the questions that you want to ask, and you just store data in case you need it later. And because of that, the idea is to store everything, and it means that for queries, you will need to scan and aggregate large amounts of data. And it means that I/O is the core of ClickHouse processing. And this is what we're gonna see how to improve, and how ClickHouse, also what mechanism ClickHouse has to speed up reading of that the large amounts of data. Because as I just said, that we are not really sure what kind of questions we're going to ask. So indexes and caches don't have limited value in this case, because we cannot know when we design our database, we don't yet have the knowledge of what part of the data is can be indexed maybe or cached. And but still, even though we don't really have that knowledge, ClickHouse allows us to deliver responses very fast. And so why columnar store is better for OLAP processing than raw store? Raw stores all the values for this these kind of funny raw stores values for the same row together. So every record is when you query raw data, you will query the whole record. You will receive the whole record together, all the values. So the store will read all the values. And for columnar store, this is the opposite. You can read just one column of data, and for that, the storage is designed so that values from the same columns are stored closer together. These differences, because of the differences in storage, it is very easy to modify rows, delete rows in a row storage, in a row oriented storage. But in a columnar store, you will have to read a lot of data to be able to delete the lot of files, to be able to delete just one row. And but column store also, because of these features, column store is very efficient for reading. If you read not the whole table and just a part of it. An example of this is a typical query in ClickHouse, and it looks exactly like any other SQL query. There are some specific features, though. You can see this even in this query. It looks familiar, but still, ClickHouse is case sensitive, and you can see that, for example, here we have a column called cancelled. Yeah, and I should mention that, so we have our test data set that we're going to be using in our classes for examples, and just for some exercises. And this data set contains the data about airline flights for several years. It is a public data set called On Time. So we're going to be working on the data concerning the flights. And there is a column called canceled. It's like if a flight was canceled, it equals 1, and if not, then 0. And you can see that the name of the column is starts with a capital C. And here we created an expression. We wanted to know the percentage of canceled flights, and we created an alias for this column, which starts with a lower c. In these are different objects in ClickHouse, and ClickHouse can differentiates them, because yes, all the names in ClickHouse are case sensitive. And another feature you can see in this query that ClickHouse aliasing works a little bit different. We created an alias for our percentage of canceled flights here, and then we used it in a having clause, which is not really supported by most of the databases. For MySQL, for example, you would need to repeat the expression in the having clause to be able to filter on it. So these are some ClickHouse specific issues that when you work with it, you need to pay attention. Or sometimes also if, okay, I'll say that. We could actually use the same. It is often people used to do that. They create an expression for a column and they alias it with the same name as the column name. And when you further reference this object, when you use this name in your query, most of the database would think that this is a column, but ClickHouse will think that this is an alias. So this is important thing to know, and many people kind of do not expect the results that they receive when they do things like that. Yeah, so this is just a typical SQL query, and okay. And now, so we're gonna visualize in the effects of how this query. Okay, so what the query does? The query actually, so this is our one-time data set. It wants, we want to calculate the number of canceled flights by year 2017, and we only want to see the numbers if for the carriers that have number of canceled flights more than 1%. So if we had a row storage, we would read every row for our year 2017 from the dataset if we had an index for year, right? So the size of the dataset is 59 gigabytes. But since ClickHouse is column storage, we only need to read 3 columns: the carrier, flight date, and the canceled column. In 3 columns, they are only 1.7 gigabytes, the size of those columns. Also, all the data in ClickHouse is compressed. So this 1.7 gigabytes becomes 21 megabyte. And also we were talking that ClickHouse processes data in parallel. So if we use 8 threads, by default, the number of threads that ClickHouse use for a single query is the half of the available cores. And for example, if we use 8 threads, that means that each thread just read 2 megabytes of data, 2.6. And comparing to what we started with 60 gigabytes, this is just nothing. And statistics for the query that we just saw, and we ran it in ClickHouse, and this is what we see. It took 45 milliseconds to process 10 11 million of rows, and it just was 38 megabytes in this case. So that was like an introduction what ClickHouse is and why it's great. Now what to do with it? We can install ClickHouse just by, so yeah, how it works. We download packages, we install packages. After a package is installed, ClickHouse will not start automatically. This is done so that you could change configuration the way you want. So when you install packages, you have to start ClickHouse manually. You can also run it in Docker, and this is like a reference for a command if you want one. I probably repeat the slides. Oops, sorry, I didn't want that. Send them in chat one more time. Okay, this is a Docker command to run ClickHouse. When we upgrade ClickHouse, this is also very easy. We just install. So this command will install the latest version. If we want a specific version, then this is how we run it. Also, ClickHouse does not restart automatically the same way. What usually happens in systems, in production systems or many systems, people just install new version of the packages, and then when they are ready, they will restart ClickHouse in the cluster. It's normally one by one, so that minimize downtime for the system. And when you restart ClickHouse, it just picks up the new version of the packages, and here you are upgraded. How to connect? ClickHouse has accepts connection in two protocols. They are most popular. The first one called native TCP client, native TCP protocol. It's used by ClickHouse client, and there are also some libraries available for this for native TCP protocol. There is a non-encrypted port and encrypted port as well. Also, this TCP protocol is used when ClickHouse nodes in the cluster talk to each other. This is also will be a native TCP protocol. HTTP protocols also has non-encrypted and encrypted ports. By default, only non-encrypted ports are going to be listening. If you want encrypted, you have to enable that separately. HTTP protocol, there are also a lot of different libraries and drivers. For example, the official JDBC driver uses HTTP protocol. But since this is HTTP, you don't really need anything, no drivers or library. You can just connect and send a query in your HTTP request, and you will receive an answer. There are some other protocols. They are working on gRPC, for example, and also ClickHouse can accept connections on using MySQL interface, but it's just there are limitations, and they are not very popular. So for most of the clients, HTTP or native TCP are the best choice. ClickHouse runs as a single process. It has a configuration stored in EDC ClickHouse server. Data and metadata by default is stored in varlib directory. It can be changed. There are also logs in varlog, which is also standard. A little bit about configuration. There are two kind of types of settings. Some of them are like server settings. They need to be defined in config XML file, and user level settings in the users XML. These two files, they come with packages. And because of that, we recommend not to modify them, because when you upgrade packages and these files have not been changed, they will be upgraded as well. So the new settings that come up with new version, they will be available, and the default settings for those new settings, the default values for these new settings will be as developers kind of wanting them to be. If you change those files, the packages will not update them. They will just put this file kind of somewhere on the side, renamed. So yeah, we recommend not to change these files manually. Instead, you can put your overrides for the default settings in config D and users D respectively. And then ClickHouse, when you add something here, ClickHouse will merge your changes with the original config file. And some of the settings are applied on the fly, especially from users D. But by default, config XML and users XML, they come as there is a question. Are they, those also shall be in XML? Oh, you mean the overrides? Yes. Yes. They while I'm saying this, right? Overrides, you can the default format for the config files is XML, but YAML is also supported. And I believe if you put the overrides in YAML, ClickHouse will be able to merge your YAML with its XMLs. So there is a choice, but definitely you should try that. I think it works. So I never tried myself that. So yeah, you can use either XML or YAML for your overrides. How can we connect the ClickHouse? So these are all the options that will work. You can just copy paste them. I believe some of them, maybe not all of them, are in that email that with credentials that we sent you earlier. So if you have ClickHouse packages installed, you can run this command. You will connect to our demo instance. This is a connection string for the play interface that is embedded in ClickHouse. So it yes, yes, yeah, someone's tested and yeah. So there are so here we there are two types of settings for ClickHouse client. This -- host equals in this example, and you also can use like -h and white space and the name of the host. So these there are different kinds of settings with two -- and just one dash. So you yeah. If you write ClickHouse client minus help, you will get the whole list of settings for ClickHouse client, and it's a lot. It's several hundred. So yeah, be careful be careful what you ask for. Another point that ClickHouse client here, there is a dash between ClickHouse and client. This is actually not a binary. This is an alias, and you can also use that without dash. So you can write ClickHouse white space client. So this is like another option for the binary. So there is only one binary. When you install ClickHouse packages, there is only one binary, which is called ClickHouse. And all the other tools or command line tools, they are actually aliases to the same ClickHouse binary. There are several, like for example, ClickHouse Keeper or ClickHouse Copier. So there are several of them, but the binary is the same. So when you install your packages, you cannot just install ClickHouse client because it is the same binary as the server. Okay, so there is also play interface, and this is a connection string for JDBC enabled UI. If you use one for your other databases, then most likely it will be working perfectly with ClickHouse as well. For our instance, we use encrypted connections, so you need to enable SSL in driver settings. Yeah. User level settings. So there are two of them, the two kinds: config XML with server level settings, and users XML with user level settings. They are organized in profiles, and there is a default profile for the instance. If you want to change settings for the whole ClickHouse server, you have to change the default profile. The default profile is described, and there is also the username default. When you install ClickHouse, they are described in the user's XML that comes with the packages. And to make changes to both user and profile, you could put your overrides in the user's D file. You can also create profiles, but it's better to use other means for that, SQL commands. You can also apply settings on the session level. With ClickHouse client, you can put them in the etc ClickHouse client config DE. There is also config XML in ClickHouse client directory the same way as with ClickHouse server. It's just there is only one config XML file, so overrides will go in config D. You can run ClickHouse client with a parameter, but pass your setting as a parameter and with the value. And also, if you use ClickHouse client interactively, you can use the set command to change a value for some settings. If you use HTTP, you can pass the settings in your URL. Also, there is a possibility to pass settings at the end of the query. In this case, this setting will only be, you're only changing it for this particular query. Not all the settings can be changed this way because some of them must be applied before ClickHouse parses the query. So there is this. So if setting the value of the setting is needed during the at this parsing stage, then passing it with the query will not help. Now we know how to connect. Let's see what we will see when we connect. We will see a database. ClickHouse databases are like MySQL databases and like Postgres schemas. Postgres databases are different. So yeah, the difference is that we can have several databases in one ClickHouse instance, and we can write queries that access data in several databases at once. So we can reference them several databases in one query. Every connection has a current database, and there is a setting. Okay, let's just probably talk about it a little later. There is a function that will show you what your current database is. So every connection has a current database. And when you access a table in your current database, you don't need to specify the database because it's the default database in your connection. To access table in another database, you have to put a name of the database in front of the table. the same as in all the other. So this is a SQL standard. In ClickHouse client, and you can use the use statement to change your default, your current database. Also, for HTTP, the name of the database can be passed as a parameter. It can also be passed as a parameter to the ClickHouse client, of course. And there are different types of connection strings for different libraries, but it is possible to change the default database for in TCP protocol and also HTTP. So there is always a way. Yes, the default database. The ClickHouse has a current database not only for user connections, but also for the whole system. Was there a question? See, some people joined. Okay. Okay, yeah, the default database. The default database can be configured, the name of it, the default database can be configured in the config XML files. If the default, you can drop the default database, but ClickHouse will recreate it. I'm sorry. Sorry about that. Yeah, so there is a default database. Yes, you can drop it, but ClickHouse will create it again as soon as you connect, or when it needs to run something internally, it will create the database. You can change the name, of course, if you don't want. So by default, the default database is called default. You can put anything in here, and so basically, it will always exist, this default database. And and then when you connect and you did not specify your default database, then your current database will be the default database. Yeah, a lot of words. Also, there is a way when you create users, you can specify a default database for the user. That's what we did when we created your accounts in our demo instance. So you don't have to specify your own database in your connection because it is like your user's property. Yeah, that's how it is. This is a special database in ClickHouse. It must, well, yeah, it always exists, and if it doesn't, then ClickHouse will create it. There is also a system database. It is a special database. Most of the tables in the system database are virtual, and you can see that if the table is virtual when you run show create table statement. Some of the tables, I think maybe always, there are real tables that store data on disk, and they have a log suffix. So ClickHouse writes a lot of logs in its system database by default. They are often they are very useful. Like there is a query log table, for example. It contains statistics about all the queries that ClickHouse ran, and some others. Query log is and there's also part log. So these tables can be very useful for investigations, the log tables, and they are normal tables that ClickHouse stores on disk. Sometimes you also need to probably monitor how much disk space they use, because people, it happens quite often, people are not aware. of such a nice feature, and they when disk space is kind of when they are running out of disk space, they start wondering what's going on there in the system database. That's ClickHouse logs, so pay attention. All the others, the other tables, they are virtual. ClickHouse, they are like structures in memory that ClickHouse builds when it starts, and then it updates them when necessary. So you cannot do anything with those virtual tables. You cannot drop them. You cannot modify them. You can't do anything. They are just for you to inspect your instance and to see what's in there. And there are a lot of useful information in the system database, and we will use some of those system tables in our exercises, and we will also see some of them, how they are useful. Basic navigation, we can show that show databases command will let us see which databases we have, and use to change the database. Show tables to see the list of tables. There is also from, so we can see what tables exist in a different database, not in our current database. Describe table will list the columns. Show create table will list the whole create table statement that we can just copy and run somewhere. Oops, sorry. And select count, of course, just so these are like basic commands that we can use to see what we have in our database, and that's what we are going to do. We can explore a little bit our demo instance, and here is the link to the exercises. Yeah. So you can use anything. You can use the ClickHouse client if you like command line tools. You can use JDBC UI if you like them. Or if you don't have anything, you can just use the play interface, the link that we sent you in the email. And the tasks are find out how many databases there are, what the tables are, and describe on time ref table in the default database, and count the number of rows. So I guess I'll just do those exercises with you. Okay, I'm going to be connecting through the play interface, and I will find out how many databases there are. So the version, ClickHouse version that we use in our demo instance, it's 22.1. It was released in January. It's just because our last, it was the latest version in our previous class. We can maybe I'll upgrade this one later, but not now. Okay, show databases. That's what we wanted to see. And I can see 3 databases, the default database, which I have the read-only access to. And there is a system database, that's the little useful information that we're going to use. And this is my database, my personal database. Okay, and I can just run show tables. And my database is empty. And if I use default, so there are some tables there. We don't know yet what they mean, but we will. And here is our favorite system database. It has a lot of tables, 81. Also here you can see that metric log table, it has like several strange tables named 0, 1, 2. What ClickHouse does during upgrade, if it sees that the structure of the, for example, here, if it wants to write metrics in a metric log table, but it sees it wants to use a special schema for the metric log table, and it sees that the table already exists, but the structure is different. So what it does, it renames the table that exists, and it creates a new one. So these 0 to 1 tables, it means that ClickHouse, the structure doesn't change often, but in this case, we can see that we upgraded at least 4 times, 3 times, and so the table changed. The structure of the metric log table changed at least 3 times. Yeah, so there was a question about the extended mode display, which I didn't know what does PSQL's X means, but there is the answer, format vertical for you can I'm sure if this work for show tables vertical. Oops, not this. Yeah, even show tables can do that. So let's if we run, for example, select star from from system something. For example, I know one table. So yeah, that's how format vertical looks. And what else was in the chat? In the play interface, is there a way to execute multiple commands? No, there is no way to execute multiple commands through HTTP protocol. Yeah, TCP, I'm not sure. I know that ClickHouse client supports that, but ClickHouse client also kind of like a heavy client. It has a lot of logic embedded, so I'm not really sure if it's a protocol accepts several queries, or if it's ClickHouse client. But HTTP for sure does not allow you to send several queries in one request. Yeah, so this is the format vertical. Is this answer the question about PSQL's X extended mode? I hope it is. Okay, so what else did we have to do? In the default database, we have it on time ref. This one on time ref, and we want to describe this table. So that's what I do, and I have an exception that this table does not exist in my database. So I need to put default in here. And here it is, the list of columns. Name, type, default expression, comment, things like that. Quite a few, 109 columns. And we also wanted to see how many rows we have in this table. What is this? 196 million. Also, show create table. How it's different from describe. This is just a create table command. So we can copy it and create this table somewhere in that place. Very convenient. Also, no, probably not also. I wanted to say that, yeah, that's actually true. Not all the characteristic of the columns can be seen here, I believe. Or maybe, I'm not sure. Well, yeah, what's the difference? The difference is this, that we can see the list of columns here, but we can see the engine. So if we want to see the engine, we have to, so this is the only way to see the engine parameters if we, is to run show create table. Okay, we'll consider it done. Next topic, schema design. Maybe I should move a little. The first data types we will create a table. We will define columns. We will define the list of columns. Within every column will have a data type. Data types in ClickHouse are a bit different, and they also have aliases that are SQL compatible, SQL standard compatible, so that so that BI tools could understand the types. And there is a system table that will shows all the data types that are supported by the version of ClickHouse. Also important thing to understand that if you can create tables using the aliases, but they will be translated to ClickHouse data types. And in fact, they will be created with ClickHouse native data types. And you will be able to see those native data types in the describe table and then show create table statement. The other thing that ClickHouse does not have primary keys and unique constraints. ClickHouse tables do have primary keys, but they are not unique, and there is no enforcing of anything. And we will talk about that in details. No primary keys means that no foreign keys either. And also ClickHouse loves white tables. It is very typical to have up to 1,000 columns in a table, and that it works well, fine, no problems in ClickHouse. Several thousand might be a problem, but one, maybe even two is not a thing. Most often, in a big data world, we'll have a fact table, and we will have also some characteristic of this. Our fact table will contain some dimensions and metrics. Metrics will represent some numeric characteristics of the data that we can aggregate, and dimensions are properties that that characterize our data. And the most often data is organized in a star schema. Then we have the IDs for dimensions in our fact table and with the metrics. And we also have separate dimension tables to store the description of our dimensions. ClickHouse, however, favors simpler schemas. And if it is possible to add dimensions directly into fact table, this is the preferred way. This way, you don't have to join, when you query your fact table, you don't have to join with dimensions, which is simpler and faster. In ClickHouse, the storage is going to be almost the same and efficient because of the compression and the columnar storage. The only problem with the single table is that data cannot be changed easily. But also in a big data world, often it's not needed, since we store events as they come. For many of the dimensions, we don't really want. We want to see the values as they were at the time of the event, and not as they changed later. But even though ClickHouse favors single table schemas, it is still possible to separate some characteristics of dimensions in other tables, and people do that all the time. And we do say that joins are not very easy to do in ClickHouse, but they are actually, and you don't have to be afraid of the joins, and there are ways to make them fast and we will talk about that. So most often these two ways are combined. For some of the dimensions, people put in just as columns in the fact tables, and some of them they extract as dimension tables. There are many table engines in ClickHouse. Here is the link to the docs, and the list is really like maybe 20 or something. But we will talk about some of them later during the course. The only engine that lets you that you should use to store your data on disk is the merge tree family. There are several of them, but they have all the same structure and they all follow the same principles. So the engine to store data in ClickHouse is merge tree. And all the others, they just help you to utilize your merge tree data more efficiently. So this is the engine that we're gonna talk about. We're gonna store data in tables of this engine, and we will discuss how to define these tables and how to optimize the storage for these tables. When we create a table, we of course list the columns and the data types and default values, maybe something else. This is the same as any other database. What's special is the engine. Here is an example of a merge tree engine, how we define it. First, we can partition a table. It is not necessary. Partitioning can be omitted. But for big tables, it is, of course, it's always better to split a table in parts, in partitions. But when you choose how to partition a table, think about data retention policies, because partitions are a very, very convenient and fast mechanism to move data around. Also, so partitioning can be omitted, but we cannot omit the order by. And data is in merge tree is always sorted. So ClickHouse stores data sorted. And the list of columns that are going to be used to sort data are specified in the order by clause. Primary key is not necessary. It can be skipped, but it always exists in ClickHouse. And if this section is omitted, then the list of order by columns will be used to create a primary key. Primary key is an index, it's a sparse index. It's used for fast search. If you so yes, if it's omitted, then it will be the list from the order by clause. Otherwise, you can define this section, but it has to be a prefix of the order by. The columns in the primary key must be a prefix of the order by. If you don't want to sort your data, you can use a tuple expression in the order by clause. So ClickHouse will not sort the data, but it will still create an index. How the data looks on disk. So the element of data in the merge tree table is a part. This is the smallest element that we can manipulate on. Part is a directory on disk. There are files in that directory. 2 files for every column plus the index. Data in this part is sorted by the order by columns. And also a very important thing to know is that all the rows in a part must have the same expression for the partition by the same value for the partition by expression. So the parts they are immutable in ClickHouse. So when you insert a bunch of data, so ClickHouse will create a part, and after that it never changes this part. So this is a directory on disk with files, and those files are immutable. If ClickHouse later, if you need to change a part, for example, you want to delete rows or update something, ClickHouse will not change the existing part. Instead, it will create a new one with the new version of the data, and it will delete the old part. So the files itself, they are never changed. And partition is a logical entity. You will not find it on disk. It's just a property of your part. Most often, partition will contain several parts, but every part belongs to just one partition. What next? So when we insert data, ClickHouse create parts. And of course, we insert often and we insert a lot. So do they always stay, those parts that got created when we inserted them? No. In background, ClickHouse constantly merges the smaller parts into bigger ones. There is a limit on the size of the part. By default, it's 150 gigabytes. So this will give you also an idea on the sizes that ClickHouse expects to work with. And ClickHouse does that to be able to select data more efficiently. When ClickHouse merges two parts, so both parts, they will, since merging of two parts will create another part, and part we know that must belong to the same partition. It means that the source part will also belong to the same partition always. So we know that the partition value is the same in all these parts, and the data is sorted by the order by, the list of order by columns. So what ClickHouse does, it reads of course, it compresses them and all the data on the files, and then it merges them. It is not very so it does not need to resort the data because they sort it the same way, all the rows, but it merges them into a bigger one and creates another sparse index, of course. And it doesn't, it's not just two parts, it can merge at the same time, like 10 maybe parts together or more. And this is done to, this helps ClickHouse to keep fewer bigger files and read from them instead of many smaller files. Now we can see, we want to see what's inside and how the data is actually stored and how all this reading works and how to use the primary key index. Sorry about that. Press something. Okay. So I said that for every column there will be two files. First file is the binary file, which contains data. And it is not that, for example, if you have like 1 million rows, there will be 1 million rows compressed together, 1 million values for 1 million rows. ClickHouse creates blocks. It compresses blocks and then it kind of stores them together in the same binary file for the data. Because of this, ClickHouse, if you ask for several rows, ClickHouse doesn't have to read the whole file. It can read just a portion of the file. And to find the portion of the file that it has to read, it maintains mark files. They have an MRK extension. So for every column, there is a binary file with the compressed blocks linked together. And there is MRK file that references these blocks and ClickHouse uses MRK files to find the blocks of data that it needs to read. And how it finds the point, how it finds this block. It uses the primary index that is not unique, even though it's primary key. It is sparse index. It has one value per granule. Granule is by default 8,192 rows. So in this example, our table is sorted by flight date and carrier. So it will have the primary index will contain a value for every 8,000 row. So this is like an example how it can look. And when we read this table and we have a filter, for example, we want to find the data from July 1st for the UA carrier. It will find this, or if there is no value for the exact carrier that we asked, for example, it will check the neighboring values. In this case, for example, we want a carrier that starts with T. So ClickHouse will find the offset for value for the previous value, and it will read all the marks that reference these two granules. It will find the offset in the MRK file. It will read this part of the MRK file, and will find the offsets for the binary file, and it will read. In this case, if our carrier starts with a T, it will have to read two granules. One. Probably, yeah, it will need to read this granule because because this starts with U already. Interesting. So this primary index allows ClickHouse to find rows in this bigger 100 gigabyte files, maybe find them very efficiently. But since all the rows values are compressed in blocks, ClickHouse cannot read just one row. It will always read first, it will read the compressed block of data, then it will uncompress it, and then it will find the values inside that block. So because of that, like key value kind of key value searches are not efficient in ClickHouse at all. But for big data, when we, for example, if we want to find like amount of flights per carrier per date, and we want just, for example, the 1st July, this will be very efficient. ClickHouse will just read the data that we asked to read. I did something bad. Okay. Data types. A lot of data types are supported. Date, time. They are represented as numbers. Date time has precision up to a second. Date time 64, you can store milliseconds, nanoseconds, anything. There is a bunch of data types for integers, unsigned, signed, different size. Two different floats, decimals with different precisions. String and fixed string, they are called string, but you can actually store any kind of byte sequence in there. ClickHouse doesn't care as long as your application knows how to interpret it. There's no problem. So this is kind of a data type. If your data is unstructured, you can put anything in a string column. There are also some special data types that for IP addresses or UIDs. Enum allows you to map integer values to names, names will be stored, numbers will be stored, and then on select, in the final stage, ClickHouse will convert those values to names. Arrays, we will discuss arrays in on our third session. There is a lot of very complex, interesting things that you can do with arrays in ClickHouse. ClickHouse does not support nulls, did not support nulls in the beginning, and when the nullable data types were implemented, it is like not native support. So every data type has a default value. For numbers, it is 0, and for strings, it is empty string. It is for arrays, it is an empty array, and arrays cannot be, like the value of an array cannot be null. It can be cannot be null. The array can contain an element that is null, but the whole value of the column cannot be null. So if you need to store nulls in a table, then you have to add a special nullable keyword in front of the data type, and it is so ClickHouse will store this nullable property of each value in a separate column. And because of that, data processing for nullable data types is always slower, because there is additional column to read and process. After we created the table, we can alter it. Alter can be, there are different types of alter processes. For example, if we add a column, it is done very fast. First, ClickHouse changed the metadata, which is not long. It just adds the records that now there is another column, and the column will not be added to the data that already exists in the table. When you read this column, ClickHouse, if there is column values for the column are not present, then ClickHouse will just populate this column with default values for the data type. If you want to modify a column, for example, if you want to change data type, this is a different story. When you change data type, the physical representation of data has to be changed. So ClickHouse will run this alter statement for the whole existing table for all the data that already exists, and it can take quite some time. ClickHouse will not block the table. The table only blocked when the metadata is changed, and then the conversion will happen in background. And during this time, if you query this column, your query can, if it tries to read from different parts of the table, both converted data and not converted yet, the query will get an exception that the types are different. But it happens in background and the table is not locked. You can also rename column, you can change the default values and things like that. So some of the alters will run fast and some of them will take time. Drop partition, there is also a lot of other partition manipulation statement that you can do. You can move partition between different tables and things like that. So this is the partition is like a logical entity that can be used to operate on the data conveniently. Like it is always recommended to choose your partition expression with data retention policies in mind. Truncate table cleans the table, of course, and you can drop the table as well. These are standard statements, and here is the list that you can see in the docs. when we create a table, if you have like ClickHouse loves white tables, we said, and we can have up to, not up to, but we can have 1,000 columns in our table, and it is not very convenient. If you want to create a copy of a table or something like that, it is not convenient to just type all the columns again. So we can use another table as a template. If we don't provide the engine clause, we can just run create table on time new as on time ref, and the table on time new will be created exactly the same as on time ref. But we can also change the engine. So the list of the columns will be taken from the our template table, and engine will become whatever we say. So this is a convenient way to create copies of tables and some other cases. Now we created our table and we're ready to load data. There are several ways and several formats. Important thing to know that ClickHouse loves everything big, and the bigger blocks, the better. And ClickHouse does not love frequent inserts because it creates a lot of work for creating new parts and then merging them in the bigger parts. And after you inserted data, changing it is not easy, and we will see how it's done. So how can we insert data? The first and simplest, and you can just run it manually by typing using values clause. The same as I'm showing MySQL is the same. You can just list several tuples separated by comma. They will be interpreted as one chunk of data. So they ClickHouse will create, in this case, a part of 2 rows will be created. But typing a lot of values, like maybe since we are talking big data, maybe millions, it's not very convenient. Very often, ClickHouse, we need to import data into ClickHouse from a different system, and it is very common that we have a file with data that we want to import. So we can just get this data to ClickHouse client. We say which format we want to use, and ClickHouse client will parse the file, will split the file in blocks if the file is too big. So if you have like a several gigabytes file, don't even think about it. Just send it to ClickHouse client and it will do everything for you. It will split the file in blocks that are ClickHouse thinks are a good size, and it will insert the data. And the ClickHouse client is like I said, it's a heavy client. It will do all the parsing, it will do all the traversing and sorting and things like that, and it will pass the converted like the blocks to ClickHouse that are ready to be inserted, and ClickHouse server will not need to do any other data processing, just create parts. Question, how frequent is a frequent insert? And is there any functionality for CH to buffer a stream of inserts and execute them in a batch? Yes, there is a functionality. It means how frequent is frequent. In the docs, they say once per second per table. But if you have a lot of tables, some people have thousands, it probably needs to be revised. Yeah, so they say once per second, but if you like, less often the better. This is what how often you can, like, how not often you can afford to insert. There are several mechanisms in ClickHouse that they're like buffer tables, async inserts that can batch data in ClickHouse, but there is not much control over that with that kind of buffering. And also it's batched in memory. So if there is a crash, like a hardware fails or something, this data will be lost. If in some situations it is acceptable, if you're like, you have like, for example, if you insert logs or something, and you can actually, if you lose some of it, it's not a problem. Sure, you can use the ClickHouse mechanisms, but if it's very important data and you don't want to lose anything, then we advise to batch it on the client side. There is no transactions in ClickHouse. Yeah, just a couple of words for other types of inserts, and we will discuss a little bit how the data is actually inserted. When you use HTTP, you will use HTTP post and will pass the data in the body of the request. In this case, so I was just saying that here ClickHouse client will parse the file and form the blocks and then do the stuff. In this situation, when you pass your file through HTTP, the server is gonna do all the parsing and processing. So these are different kinds of things. It depends on how you want to, where you want your parsing to happen. If you want your client to be light, you will probably use HTTP. If you want your client to be heavy and kind of save some resources on the server, you can run ClickHouse client on a different machine and make it do all this parsing stuff to save some resources on the ClickHouse server machine. So these are different approaches, but they will kind of do the same thing. Several formats exist that you can provide data in. Some text formats like CSV. There is also TSV is very like a default format for ClickHouse, is tab separated. JSON, of course, JSON each row is a special format. Each row represents a JSON object, but the whole file is not a valid JSON. So this is, if you want to use this, pay attention to that. Of course, this very popular format for data exchange and with different systems supported. There probably could be limitations for some of those formats, and some of them were implemented by third-party developers, and there could be some bugs, and some, of course, many of are already fixed. But yeah, you don't know for sure, but what's happening with me? Okay. You can try if you have data in all those formats, and you can just try insert in ClickHouse your data the way you have it, and there is a high probability that it will just work. Another way to insert data is, as we created a table as a template, we can also insert data from another table, selecting from a table and then inserting. There are also different functions. They are called table functions. They let you read data from some external source. Like here we use a S3 function to read from an S3 file on S3. And there are from others like MySQL or Postgres, for example. You can there is a list. The list is here in the docs. There is also input function. So what they do. So you provide the source for the data. For the S3 function, you have to provide also the access key. Then you say the format of what is the format of the file and the structure of the file. And then ClickHouse reads this file from the source, and in your select clause, you can convert the data in this file to so sorry about that, to match the structure of your target table. For example, it might not have, so here in the file we have 1, 2, 3, 4, 5 columns. Maybe in the table we have only 4, or maybe we have 6 and we need like to calculate an expression for the 6th column. We can do this in the select clause. An input function, it's also a table function. It lets you just read file from a disk, from disk, like ClickHouse client, for example, does, and then kind of convert this data. So when you need to, so you have a file, but your data table structure is different. This is how you can insert data without converting your source file. Insert, how we insert. ClickHouse does not have transactions yet. They're working on it, and they expect the first version to be released in April, actually. But at this point, ClickHouse does not have transactions. And if you insert a lot of data and the insert got interrupted in the middle, we are not really sure what got inserted and what not. Sorry about that. So the question was in the chat for the data loss, if there is a val or similar. Well, it is a complicated question. So we were talking about how to create a buffer before the merge tree table to insert in bigger batches, right? And there are different approaches to that. For example, there is a buffer table engine, and it is in memory engine. You just insert into that table. It will store data there for some time, and then it will, when it's time, when there's you can configure this buffer, when, how often, and stuff, and it just flushes the data to merge tree table. If there was a hardware failure during this, well, the buffer wasn't empty. If the buffer didn't flash anything in the merge tree table, the data is lost, like completely. There is a different type of parts in ClickHouse called in-memory parts. This way, what happens when you insert data into ClickHouse, it is, so the same process will be kind of, as for normal image tree process will be, will happen. The only difference is that the part will not be created on disk, it will be created in memory. It does not help a lot. We don't really recommend to use that, and there are problems with those kinds of parts. And since not a lot of people use it, it doesn't work very well. Let's say that. And for this kind of parts, there is a well, I don't know how to, what's the abbreviation stands for. Well, so this, and if there will be a failure, those parts in memory parts will be right. Thank you. So this in memory parts, they will be recovered. There will be no data loss. There is also asynchronous inserts, and they are also in memory, and they also will be lost completely the same as a buffer. They don't have this write-ahead log. So yeah, there are different options, but the preferred one is to construct the bigger blocks on the client side, also because you have more, in this case, you have more control over how you insert data and what exactly you insert. And this is important because ClickHouse does not have transactions, but blocks of rows are inserted atomically. And for example, if you have like a really huge file, like 100 million rows, and you just have a file, you want to load it, you push this file to ClickHouse client, it will parse the file, it will break this data into blocks up to 1 million rows, and it will insert those data block by block. So for 100 million file, you will get 100 blocks, and every block will become a part when the processing is done. And so these blocks of data, 1 million rows out of the file, of the whole file. If there was an exception, like some value wasn't parsed or something, the whole block will be discarded. And why it's important? Because because no transactions, but there's still exceptions. And when something happened, either exception or you just don't know what happened, and for example your client did not receive, like you sent your file through HTTP and then you didn't receive an answer and connection just terminated, right? So you don't know what happened, and you just repeat the whole insert, your whole file, you send it again. What ClickHouse will do, it will process the file the same way as it just did. So it will form the same blocks of data. And there is a deduplication that when ClickHouse forms the block and it's ready to be inserted, and ClickHouse calculates the hash sum for this block, and it stores it for replicated table, it stores in the Zookeeper, or for merge tree table, it will store them on disk, and it calculates the hash sum and it creates a new part. If you have to repeat the insert, and ClickHouse will start parsing everything again, and it will create the same block. It will calculate the hash sum again, but it will find the same hash sum in the list of inserted blocks, and it will say, "Oh no, I've already seen that block, and I will just discard it." So this way, you can, even if so you inserted like 100 million, you were inserting 100 million in rows, and then an exception happened somewhere in the middle, and you don't really know how many rows got inserted. You just repeat the whole thing, and ClickHouse will it will discard what was already inserted, and it will insert what wasn't. And I was kind of talking about that for so long, because I wanted to say that when you start using these data buffering mechanisms on ClickHouse side, this deduplication logic is not going to work, because ClickHouse will not be able to form the same blocks as it did the previous time, because we just don't control the buffer. And normally when people have the buffers, it means that inserts are coming from different sources, like maybe different clients insert into the same table, and this data will be mixed in those buffers. And when the clients have to repeat their inserts, they will be mixed in a different way, and this deduplication logic won't work. So this is the other reason why we suggest everyone to buffer on the client side. And yeah, and there is the whole article how to define how to figure out what is the size of the block that ClickHouse will insert. There are a lot of settings to control that. And yeah, normally you don't have to think about that. because you insert data. If something failed, you just repeat, and ClickHouse deduplicated itself. But in some situations, you really, if you want to know the internals and how it is happening, then it can all be figured out, and there are ways to know how exactly ClickHouse inserts. And I invite you to use this article as a reference. How to update? The updating and deleting ClickHouse is called mutations. And these mutations, they implemented as a part of alter table syntax, just to point to people that it is not an easy thing to do. So it is not just like, so you think that select is a query, and then update and delete and insert, they are kind of like DML things, and then alter, you consider a DDL query, right? So here the ClickHouse team, they wanted people to know that alter, so these mutations, they considered like a table changing kind of operations. So they implemented as alter table, not just update and delete. This is because the parts are immutable, and to delete, for example, we have a part of 150 gigabytes, and we want to delete one row from this part. So what ClickHouse, it cannot delete the row, the part is immutable. So what it will do, it will read the whole part, uncompress everything, and then while it will be creating a new part, it will remove that row that is not supposed to be there anymore. So it will create a new part without the rows that need to be deleted. This is, of course, a very heavy thing to do. And update is a little easier because it just needs to update one column, not all of them. But still, it has to, the whole column has to be unpacked and rewritten. Mutations run in background. There is a special system tables called system mutations that stores the list of mutations that are. So it actually stores it is cleaned periodically. I think it stores not more than 100 mutations per table. There are a lot of columns, not just these two, and you can see the mutations that are registered, if they are done, and how many parts they processed, and all this stuff. Sometimes another thing with mutation, if there is an exception, for example, if we here what we did, we wanted to change this from this. It happens often when you, for example, want to convert your you have a string value and you want to convert it to a number, for example. There could be exceptions, like if some data cannot be converted, like there are letters in there or something, and there will be an exception. And but mutation cannot stop on its own. It will try forever to update the value. So the only thing to, so you need to, when you issue a mutation, it is always a good idea to monitor that it ended successfully. If something happens and it cannot be finished, you can kill it. In a where clause, you can use any column from this system mutation command. And you run kill mutation will be interrupted. And you can correct if your statement wasn't doing what, like if there was exceptions, you will see something wrong. Then it couldn't convert like strings to values to numbers or something, you can correct your statement and run it again. Also, mutations are lined up. If you, in this case, if we issue an update statement, and then we issue a delete for this new value, this delete will be performed after the update finished. The question, what are the implications of killing a mutation in terms of the data? Given that there are no transactions, I guess part of the data could be modified and the rest may still be left untouched. That's exactly that. How mutations work? So the part, one part in a table is the smallest unit of data. So mutation, they process one part at a time, and they run as the same way as merges run. So they will read the whole data, process the data, and then create a new part, and they will mark the old part as inactive. So if mutations cannot process this one part, so that part will contain not updated or not deleted data, but the other parts can still be processed. So they process asynchronously, independently, and separately. And for example, if we had 100 of parts in our table, and then we run this update statement, and it ran successfully for 99 parts, and just one part was stuck, then we will run the delete, which will be lined up after the update. The delete will process the 99 parts as well, but it will wait for this for update on the last part to complete, and so it will be waiting forever then. And so if you interrupt mutation in the middle, yes, you will have like half a table updated to half a table not. But I guess you can just rerun. It depends on the query, of course. But yeah, but even when mutation is running, you still will have some data in inconsistent state, because it runs in background in one part at a time, and you will see, for example, while this update is running, you will see some of the rows with 0, 0, 2, some with 0, 0, or I'm not sure what that, until mutation is finished. So yeah, you will have to repeat that somehow to get into a consistent state. Second exercise. We will create a table, and we will copy data, and we add the column and count the number of rows. Let's just do this real quick. I'm not sure. I probably I won't have enough time to do everything. Okay, create a table called on time using the schema, or we can do this. We can leave this for you to do at home. That's not that one. If I have the answers, so I can do it quickly. Okay. Someone wanted to know. Okay. So we need to create a table called on time using the schema of default on time ref. This is the default on time ref that we have, and the problem is that we here have a replicated table. We don't know what it is yet. We will learn it next week. So we cannot really copy the engine parameters. We have to change them. We have to remove that replicated thing. And this is how we will create it. Here, I have a table. Copy data. Interesting. Typo. Copy 2017 data from default on time ref. to your on time table. This is how we do it. Ta-da. Finally. Okay, we can then probably they will ask, okay, let's see how many rows we got. $5 million. Okay. And the string column called nodes to the end of your table. Oh, count the number for that, did you that? Okay, add the string columns. Ta-da. How many parts are there? So let's just see that my column is there. It is. And to see how many parts we have a query. So this is my 5 million rows. This is 6 parts. And this is the size, compressed bytes, 455 megabytes. And this is uncompressed size. Uncompressed size is 1 gigabyte, let's say. Okay. Wipe out and load again. We won't do that. We don't have too much time. Okay. If you have any questions about that, then we can discuss this next time. And I'll just talk really quickly about optimizing the schema for performance. And in ClickHouse, optimizing schema most often means that we want to make ClickHouse read less data from disk. So we want to reduce I/O because that's the biggest part of query processing in ClickHouse, to read a lot of data, then uncompress, then something else. So there are several factors that we will discuss today that influence the amount of I/O that ClickHouse has to do. Is the partitioning, sort order, and compression. To see how partitioning expression affect the query's performance, we will create three different tables with same data, same structure, but different partitioning. The first one is the one that we just created. Okay, partitioned by month. The second is partitioned by date. I believe that we partitioned hours by year. Yeah, it's partitioned by year. And this one is partitioned by months. The second is partitioned by date. And the third is partitioned by months and also by career. So we inserted data into the table the same way as we just did in our exercise. And we can see this, all three tables, they have the same number of rows and they have the same number of uncompressed bytes, which is the number of rows multiplied by the size of the data types. They have different number of parts. This is the smallest is partitioned by months. This is partitioned by day, and this is months plus carrier. Also, we can see that it affects the compressed bytes, the size of the table, physical size. So this is the tables that is partitioned by carrier and the months. It takes a little bit less space because, of course, all the carriers are in the same partition. So one partition contains only one carrier. So compression, at least for one column, and it is at least for one column is better. For table partition by date, the size of the table is a bit more, it's a bit higher, just because it is split in a higher number of files. Because for some files, ClickHouse wasn't able to benefit from many values compressed together. And how, but yeah, the size is not the most important thing. The most important thing is the number of files and how it influences our query. Here, there was a simple select count that just read one file from disk and calculated the number of values in it. And we see that for our on-time table that has, so the numbers are different from the previous slide because there are more rows. So this is not just 1 year. This is the whole table for several years. And when table was partitioned by months, there were 355 parts, and it is it took 340 milliseconds, yes. And for the table that is partitioned by date, it turned out with 14,000 parts, and the time spent by select count query was 10 times higher, just because it had to read and scan more files, like much more files. Oops, sorry about that. So that's how partitioning affects I/O. The important thing to remember when you choose partitioning key is to keep it simple, because ClickHouse can also eliminate parts. If there is a filter in the query on the columns that are in the partitioning expression, ClickHouse can calculate the values for those filters, and it will just skip the partitions that do not contain values for this query that this query wants to read. And if partitioning expression is very complex, then ClickHouse might not be able to figure it out. So the filtering on the columns and the partitioning expression will not help to speed up the query. This logic is actually quite complex in ClickHouse. So for many, even if you apply a function, if you partition not by a column value, but a function on the column value, ClickHouse might be able to figure this out anyway. So if you want to create a table with a complex partitioning expression, just check if ClickHouse is able to figure out these filters that you're gonna use in your queries, and yeah, keep this in mind. Keep the number of partitions small, because it is, as we just saw, that higher number of parts influence queries in a bad way. And also insert blocks to hit the smallest number of partitions possible. It also, so when we were talking about ClickHouse splitting data that you insert into blocks, it will also split data into several blocks if the block of data consists rows from different partitions, because blocks equals the part, and part cannot have different values for partition expression. So if your data block that you want to insert, like let's call it chunk of data that you want to insert, contains rows from different partitions, there will be several blocks created and several parts, and then the merging activity will also be increased because of that. So yeah, it is also, you need to keep this in mind when you try to find the optimal partitioning expression for your tables. And yes, if you're not sure, just partition by months, and you just can go from there, and you will optimize your queries when you run into issues. Another way to make column smaller is to change the compression method. By default, ClickHouse compresses everything with LZ4. But there are also some other compression methods that can be used. For ZSTD is a very good one, very popular. There is a server level setting. If you change that, the data for all the tables are going to be compressed with the different compression methods. This is very convenient. A restart is needed for that parameter to take effect. But it is just it is an easy way to change compression method for everything. Otherwise, you can change it on the column level, and in our example, we will look at the tail num column in our on-time dataset. This is a string column. It's not very long, just 6 symbols, but we'll see what we can do. So this is the size of our column as it is now. We can probably run this query, and we will see that these numbers. So this is uncompressed size, and compressed size is 19 megabytes. So the ratio is about 50% at the moment. We will change the compression method to ZSTD for our column. This is a metadata only change, because ClickHouse can process data compressed with different kind of codecs from different parts. It doesn't really have to be the same for the whole table. So to see if this will help us to decrease the size of the column, we will have to run a mutation. We will need to, this is like a fake mutation. We will update tail num with the same value for in the whole table, just to make ClickHouse rewrite this column. So it will recompress it with the ZSTD instead of LZ4. And here's what we see, 12 megabytes instead of 19. Nice increase. But we can do better. And to do better, we can change the sort order. If we add our tail num column to our order by expression, then we will have similar values together, and it will help our compression algorithm to decrease the size of our column even better. So how can we do that? We cannot change the order by the sort order for the existing column, table, because it will we will have to resort everything, right? Instead, well, it's not instead, but there is no other way. So we will create another table. We will use the previous table as a template, and we will change the engine. So we will add the tail num to the end of the order by clause, but we will not add it to the primary key list. And then we reinsert the data. And here is the result. And instead, so we started with 19 megabytes, and now we have 2, so it's almost 10 times, right? This was cool, I think. So there is another way we can reduce the data size for string columns. It's called, it is a different kind of data type. It's called low cardinality. So what it does, it creates a dictionary from a value, from the value of the column. It creates a dictionary with the distinct values, and it codes every value with a number, and it will store in the column, in the binary file for the column numbers, and the dictionary will be also stored in a separate file. and it will help. So instead of 6 bytes for our string column, we will store 2 bytes for a small integer. And we also apply compression, so that's gonna help a lot. I guess this is almost the last slide. Yeah, I'll just finish, and if anyone needs to go, then of course. And the recording, we will send the recording, so you will be able to listen it later if you have to go. Okay, so overview what we can use to decrease the size of our columns. We can use the low cardinality data types. This will create a dictionary. The dictionary is local to the part, so every part will have its own dictionary for the values of the columns. So it says that strings with fewer than 10k values, but this is in the part, not in the whole table, because dictionary is local to the part. This is a characteristic of data type. So if you want to apply this low cardinality encoding, you have to change the data type. This are codecs, and they don't. So they just can be changed really quickly, and they will. If you change a codec, it will be applied to new data only. So there are 4 of them: Delta, Double Delta, Gorilla, and T64. So Gorilla is only useful for floats, for float data types, and Delta, Double Delta for T64 for integers and date-time values. This, of course, all depends on the data that you have, and it is always good to check which codec is better for your data, and some of them might not be helping. And also, if you want to use a codec like that, it also need to be compression has to be added on top of the codec. So this is examples how to add them. If you want low cardinality, then we need to modify the data type and then apply compression codec. If you want, we can also just use a default one. It's a different thing. They don't have to go together. When we want to apply codec on integer column year, for example, so this is how we do it. We apply codec, and then the second parameter will be a compression method. So for every codec, when you apply a codec, you always have to add the compression method as well. If you omit the compression method, the data will not be compressed, which is not very well. Which is not very good. Yes. And then to change data, we don't really need to run this for the tail num because we changed the data type. But for year, if we want to apply this codec to the previous data, we have to run a mutation. And this is just visualization of how codecs and compression work together. So uncompressed data is just the size of that type multiplied by the number of rows. And then when we apply codec, yeah, these numbers are very impressive. But then, so what I wanted to say on this slide is actually when you apply a codec to your data, you always need to apply the compression as well, because codecs with compressions, they don't decrease the size of the column. Well, it shows here, but it's compared to uncompressed data. If we compared with the data compressed with LZ4, I probably should change this slide that, because most likely that column compressed with LZ4 was like 25% here. So this difference is really not that small between a codec and codec compressed. Is there any mechanism to mask or obfuscate column values? You mean on select probably, right? Or there is encryption. You can store some column unencrypted. If that is what you're asking. Yeah, I think that maybe encryption is a mechanism. If you want obfuscate column values, there is a tool called obfuscator, but it's supposed to be used if you want to, like, for example, send your data to a support provider and you don't want them to see the data. So this obfuscator thing, it will run on your data set. It will like come up with something that is similar to your data, but not your data. But yeah, I'm not really sure why, when you want to, how you want to use this, like create card number. But so you want to, like when you select this data, you want not see it, or you want some people not see it. You can maybe restrict access. So yeah, there are ways that you can hide data. So,
yeah, are you able to hear me?
Yes, yeah.
I'm sorry for that. So yes, so I want some people not to see the data, like some sort of masking, like say, there's a credit card, right? Number, or social number, we masked only for specific people, or when the query is made, that should be unassumable. Otherwise, the support or SRE people can see the all sensitive information. So is there any mechanism in ClickHouse which allows us to do that stuff?
Well, you can encrypt, you can like encrypt some of the columns, but then to see the values, you will have to, like, for people who can see and for people who cannot, you will have to run different queries. So yeah,
okay,
something like that. Masking.
yeah, but at the table creation level time, we can say these columns need to be encrypted, and these are the keys, and this is how you decrypt it by using special something.
I think so. I think I just wanted to find like.
Yes, most of the databases support masking, and it is a little bit different than encryption. Encryption plays into a lot of keys and other things.
So how can you, the table level? I will have to, so to here they insert encrypted values. Yeah, I'm not really, don't have an answer for you. Like that on the table level, like you would define something that will, I don't know, nothing comes to mind. I don't know.
So maybe I can follow it up in the next.
Yeah.
I'll have to read this thing too. Okay.
I will make a note of your question. See, maybe someone else knows. And that was the last slide. We have an exercise. How to apply different compression methods and codecs on different columns, a string column and a numeric column. And we invite you in this untimed table, find the column that you want to exercise on and do something with it, like apply low cardinality or a codec. Actually, yeah, so maybe that was also we wanted to say that for strings, there is no codec that could be used. The ZSTD compression method is actually works very well for strings, because it works kind of like the dictionary encoding thing, but it doesn't encode the whole values. It can encode like parts of values. So that ZSTD is very good for strings, but if you want to apply something, like if you have low cardinality is also a very good method to decrease the size of string columns. And for numerics, you can use the codec. And yeah, so please do this. There's here there is a, yes, this lab 3, there is a like the task and some examples that you can modify to do what we are asking you to do. So please try it, and we can discuss what your results on Thursday. And another question, low cardinality values less than 10,000 and tox is 100,000. Yes, yeah. So the question is that we provide different numbers. Every time we mention that, we provide different values. So this slide says 10K, and the docs says 100K, and then this value says even 10 million somewhere. I'm not sure. I believe that because we don't know for sure. Even tell me, I know that a very good example that I was able to improve a lot the storage of using low cardinality. I improved a lot the storage size of the size of the user agent column. You know, it can have very distinct values, but I think that maybe what's important here is the number of unique values per part, not per table. And this number might be very different. In a table, we can have like hundreds of millions, but then in a part, depending on how the table is partitioned, it might be that the number of distinct values is not that big, right? So this is so the problem is if you have a lot of distinct values, and so the list of these distinct values is going to be really huge, and there is also a limit. So in one dictionary, ClickHouse can store only up to several thousand, I think, unique values. And then if there is overflow, there will be some additional files created and something like that. So yeah, it is something to kind of monitor. And with higher, like this bigger dictionaries, it can also sometimes probably not slow down the whole processing, but I don't know, maybe in some cases it will. So you will see that the data for the column is not maybe that huge, but then the dictionary grows. There is a virtual column called part, and when you investigate that, let's see. Select. So this is the part name, and when you investigate this low cardinality dictionaries and stuff, you can group by this virtual column, and you can see how many unique values you have. Unique we were investigating tail num, for example, right? So we can see that per part we have that many unique values. This, of course, we can see also that they are different. The size of the parts is different. So for smaller parts, we have less values, fewer distinct values. And for bigger parts, we have more distinct values. So when you're thinking about that, also can check this. Can like where here, I don't know which where, for example, months equal 1. Right. I'm not sure why you would do that. Oh no, if our table was partitioned by month, we would see not all the parts, just the parts that belong to. And we can, if I use default on time, ref is partitioned by months. No, it's also partitioned by year. Oh, yeah. If you wanted to see just some of the parts, or you can say part. Two 2007, for example. Yeah. So yeah, that's so you can see, and also if we remove that, so we saw like several thousand of unique values, and if we query the whole table, we will see like 18,000. So yeah, for the whole table, the number of unique values is more than for a part. This is yeah something. Okay. Oh wow. I sorry about that. Yeah, it was like a little bit too long. I'll try to do better next time. I'll try to speak faster. Okay. Thank you everybody for your questions and for being here. And yeah, we will send the recording, and I've already sent not me, but yeah, we will send the links to the exercises and the PDF with slides and the recording as well. And I will see you on Thursday. Thank you. Bye.
Thank you.
Thank you. Bye-bye.
Bye.